Hello, my name is Maya Laliker, and welcome to this lecture on muscle contraction. So to begin, we are going to need to generate an action potential. So sodium ions on the inside of the neuron are going to be pumped out through the sodium-potassium pump, while potassium ions are going to be pumped inside. This is going to create a positive charge on the inside of the neuron, which is going to kickstart our muscle contraction process. Where we are going to be located in the majority of this process is going to be the myofibril and the sarcolemma. They are contained in many tubules, as you can see here. So once we have done our action potential, we are going to be looking at the motor neuron coming to the muscle fiber. The area in which this occurs is called the neuromuscular junction. We are going to see acetylcholine released from the vesicles and into the muscle fiber and seeing the receptors there. This process is then going to allow calcium to be released through the sarcoplasmic reticulum. The sarcoplasmic reticulum is a fibrous tissue that runs throughout the sarcolemma and the myofibril. This is a very advantageous spot for it to be because of what happens in our next step. Here we have myosin in orange, myosin heads in brown, and actin in red. These are our actin and myosin, our two major proteins in our muscles. In purple here we have the troponin-tropomyosin complex, and the release of calcium is very important here because it releases this complex from the actin. And the release of this complex allows the myosin heads to grab onto the actin like you see here. Once the myosin heads grab onto the actin, ATP is going to come in and fuel the pulling of the actin. It's going to come in this way. If we're just looking at the right side here, it's going to come in and pull towards the center of the myosin, and this is what is going to generate that contraction. So at the very most contracted phase, this is what it would look like on the protein level. In order to release our contraction, because it is not advantageous for us to have our muscles contracted all the time, we are going to need magnesium and ATP to release the myosin heads from the actin and reform our troponin-tropomyosin complex. So after that, that is what that will look like here. So a tiny little review: when your muscles are contracting, this is what you're going to look like at the protein level. The actin comes inwards. When you release, the actin comes back out and the troponin-tropomyosin complex reforms. I would like to end by thanking the National Library of Medicine for the extra information needed for this lecture. And I would also like to thank you so much for watching and the consideration for this amazing scholarship. Thank you so much.